Hello, welcome to a new video. This will be a series on LLM inference. Let's just jump into it. So let's see. So at a high level, if you look at most model architectures today, they basically look like this. There's some bells and whistles, but for the most part, you have an input, you'll have an embedding layer, you'll go through a bunch of transformer blocks, you'll do an RMS norm, you'll do an LM head, and then you'll have your output. And so for this lecture, I just want to kind of build intuition on like what this means in practice. And then in the future lecture, we're going to really deep dive into various parts of this, especially the transformer. But we're also going to dive into kind of the surrounding infrastructure around this. So things like the KV cache, speculative decoding, disaggregated, prefill decode, etc. Okay, but for this one, we're just going to build intuition, okay? So imagine that you have the prompt, the cat jumped. So in modern LLMs, what we're going to do is we're going to tokenize this prompt. Typically, you're going to tokenize at a sub-word level, but for the sake of our example, we're just going to tokenize at the word level. So what this means, what tokenization means is we're basically mapping each word into an integer. So the becomes 53, cat becomes 2004, jumped becomes 20,302. And then we're going to go through an embedding layer, and what this means is for each integer, we're going to look up a corresponding vector of floating point numbers, and this is like the representation of the token. So like the is represented by this list of floating point numbers, cat is represented by this. And the reason you want this is so you can have a richer representation. Okay, and what is a transformer? A transformer basically takes this, 3 by h, we do let's say it's 512, so 3 by 512 tensor, and we're going to just transform it over and over and over again. And you'll notice when we say transform, we're transforming the values of this tensor. We are not changing the shape. And so you can kind of represent this abstractly as like, you're going to have like A1, A2, .n, representing the embedding for 53, B1, B2, .bn for 2004, whatever. And then it's going to, as it goes through each transformer layer, each value is going to get transformed. And at the very end, what we're going to do is we're going to project this intermediate representation into a tensor that is the size of our vocabulary. So you might think like the Merriam-Webster dictionary, right? So let's say there's like, 500,000 words. Then there's going to be 500,000 elements in here. And what we're going to do is we're going to normalize it so that they're all probabilities, and the sum of them is 1. And there's going to be one element in this that has the highest probability, and that represents our output. So going back to this example, the cat jumped, over is probably a high probability word, might have like 0.32, 32% probability. And then so in practice, what these LLMs will do is they'll say, give me the maximum probability element in this, and then we'll map it to the corresponding word or token, and we get over. So hopefully this builds a very basic intuition on what is going on when we go through a transformer. In subsequent lectures, we're going to really dive deep into the complexities of this. In particular, how do we do this at scale? How do we do this efficiently? And stuff like that. So see you in the next one.